My name is Hunter Costello, and I'll be going into Lab 3 for EEE120. Our first circuit we're looking at is the 4-bit register with an enable. So with the 4-bit register, in order to change the value of Q, you have to first pick a different value for input D and enable the 4-bit mux so it passes through D. And once you do that, you raise the clock and it changes the value of Q to D. If you have the enable lowered, say D is 0 this time, it's just instead of passing D, passes Q through it and results in the same value. And whether clock is up or down, reset will reset it back to 0. Our next circuit is the program counter. All this circuit does is, if enable is up, and each time the clock raises, it just increases the value of Q, going through the incrementer and putting it back through D. Though if enable is lowered and you click clock, nothing happens. And whether clock is raised or lowered, reset will always set Q back to 0. Just going through all the numbers again. It'll eventually reset once you reach F. It'll just go back to 0. The third circuit we're going to look at is a RAM finder. So in this circuit, address is going to look for an index of RAM. So we're given this ramvals.hex file, and this is the starting value. The index number increases each time you go down a line, and the index of this first number is 0. So we see that address is 0 and it's outputting 3. So if we change this to address 1, which is the only one with a different value, it's going to output 5. But say we want to add a value to the RAM table. So we're going to choose an address. In this case, we'll just go to 2 because it's the next one. And we'll set data into 6. And if we hit right and then raise the clock, it'll change that hex value to 6. So if we take these down, go back to 0, you see it's still 3, 1 is still 5, and now 2 is 6. And this essentially just lets you change the value of a hex index. And the final circuit we'll be looking at is the brainless.dig, which is a microprocessor without a controller, as I will be acting as the controller. So we have all these. We have ones from previous labs, the ALU 2 4-bit muxes, and 2 other circuits, the program RAM and 4-bit register from our lab this time. And we see that there's way more inputs than there was before. So through the lab, we are given directions on how to use this. So I'll follow those. First, we set read to 1. And what that does is it takes, since the address bus is 0, it goes down this wire to the program RAM, and the data out is going to be address 0 in the hex values. So that's going to be a 3. And since select is 1, it's going to send that out to the accumulator. And since this select is lower down here, it'll send it to the data bus, which routes it back to the A over here. And so then we raise pass, which passes A to the ALU out and the accumulator. And if we do load accumulator, it'll pass that out here once we read clock. And we see that the accumulator here is 3. And now we want to add another number. So we're going to add 5 in this case. So we're going to set the address bus to 1. And we see that now the program RAM is setting a 5 over here. And that's going to be passing over here to A. But now what we want to do is add the accumulator and this 5. So we click arithmetic. And then we click clock again, or we raise it again. And we see that the accumulator outputs 8. And we can do many tests with this. I'll throw up the waveform I have for it right now, just to test the different ways I went through it. I essentially just each time kept the value from before and just did a continuation of it. And that is all I have for Lab 3 this time, and thank you for watching.